Okay, let's take a look at question 6. So we have this function. It's defined right here for all values greater than 0, and k is a positive constant. And they want us to find our first and second derivative. So I am going to first rewrite this, written as k times x to the 1/2. So I'm ready to do my power down rule, minus ln of x. So for part A, my first derivative, use your power down, so you'll have 1/2 times k, x to the 1 less than that, negative 1/2. And the derivative of ln of x is just 1 over x. And I will go ahead and simplify this, which gives me k over 2 square root of x minus 1 over x. And then our second derivative, I'm going to rewrite my f prime as the k over 2 x to the negative 1/2 minus x to the negative first. So I'm ready for the power down rule. So now as we use the power down rule, I'll have f double prime of x equaling negative 1/2 times k over 2, x to the 1 less than that, which makes it x to the negative 3/2. I'm going to bring down my negative 1, so it becomes plus 1. 1 less than that is negative 2. And then I will go ahead and rewrite with positive exponents. Okay, so now for part B, it says, for what value of the constant k does f have a critical point at x equals 1? For this value of k, determine whether f has a relative min, relative max, or neither. Justify your answer. So what I'm going to first do is plug in 1 for x into my first derivative. And that gives us 2 square root of 1. So I have k over 2 square root of 1 minus 1 over 1. And we know that critical values happen when our first derivative is set equal to 0 or undefined. So I'm going to do that here, and I get k over 2 minus 1. This will never be undefined, so I'm not even going to include it. I'm going to add 1 and cross multiply. And we have a critical value when k equals 2. So now what we need to decide is determine whether f has a relative min, relative max, or neither. So what we can do is use our second derivative test to decide, since we have our second derivative. So let's look at our second derivative when x equals 1. We have negative 2 on top, because that's our k value is 2. 4 times 1, which is just 4, plus 1 over 1 squared, which is just 1. And f double prime of 1 is negative 1/2 plus 1, which equals a positive 1/2. So let's think about that. If our second derivative is positive, that means it's concave up, okay, which makes that point there at 1 a relative min. Okay, so it does to justify your answer. So we will say that it's a relative min because f double prime of 1 is greater than 0 and f prime of 1 is equal to 0. So we know we have a critical value there, and we know this is a minimum because of this by our second derivative test. Okay, and then part C, for a certain value of the constant k, the graph of f has a point of inflection on the x-axis. Find this value of k. So if there's a point of inflection on our x-axis, so that means it's going from concave down to concave up there. But notice what's happening there. is that's your function value there. It's 0, okay? So we want to look at our original function and find what x value makes that 0, okay? So if we set that equal to 0, our original, we get k squared of x minus ln of x. If I move this over, I get ln of x equals k square root of x, and we don't know what our k value is, so we notice we do have 2 unknowns, okay? The other thing we know is that there's a point of inflection there, and so those are zeros of our second derivative. So we're going to take our second derivative, which is, I feel like this is kind of getting jumbled up here. So our second derivative is, we're going to set that equal to 0. And again, you have 2 unknowns. So you do have a system of equations here. So I'm going to move this over. I'm going to cross multiply and divide. So I'm going to get k equals 4x to the 3/2 divided by x squared, which gives me k equals 4x to the negative 1/2. Okay? Now, if both of those equal k, we can set them equal to each other. Okay? So ln of x all over radical x equals 4 over, I can even do that as square root of x, that's fine. So when I cross multiply here, I get radical x, ln of x equals 4 radical x, divide both sides by radical x, and ln of x equals 4, meaning e to the 4th equals x. So our overall goal here was to find that value of k where that happens, and probably our easiest place to plug that into is right here. So you get 4 over the square root of e to the 4th. So k equals 4 over e squared.